All right, George Anthony, let's see what's going on here. We'll get that out of the way. Okay. So they're nice enough to give you the equations up there. Okay. And they want to know, in the very first situation, how do you determine if an object is moving? It has to change position over a change in time. Okay? All right. The ball rolls a distance of 5 meters in 3 seconds. What can be determined from this information? Well, length of the roll, distance of the roll, average speed of the roll, those things would work. If an object is thrown upward, what is velocity and acceleration at the top of the path? The velocity has to go to 0 for just an instant so it can return to the Earth. Gravity has slowed it down to 0. The acceleration never changes. It's still 9.8 meters per second squared, and it's directed to the back to the Earth. 2 ways to change your velocity. You can speed up or slow down while moving in the same direction, or changing directions would be the second way. You can keep your speed constant, but your velocity will change if your direction changes. An example of that would be, let's see if I can find, there we go, things that move in a circle. So if I go in a circle and I go at 5 meters per second the entire time, my speed never changes, but my direction always changes. If I look at my direction, let me scoot back some. All right, if I look at my direction, here's my direction, my velocity vector there. Here it is there, and these are supposed to be drawn tangent. You can tell I'm not much of an artist. So that blue one, that's my velocity at 4 different points in time, while the value, the speed is staying constant. The direction is always changing, which is meaning I'm accelerating or changing my velocity. So that's what they're talking about there. All right. In the absence of air resistance, any object that takes 10 seconds to reach its highest upward point will take 10 seconds to go back. Okay. Start from rest. All right, so VI plus AT. You know this is 0. You know A and T. Go for it. 7 says, including an hour-long trip for lunch, what is the average velocity when traveling a distance of 180 miles? So total distance over total time. If you move 20 meters towards your origin, which is 60 meters away, what is your displacement from your starting position? All right, so I'm assuming this is my origin. This is my 60 meters. And I have moved 20 meters toward it. So now I am 40 meters away. So I'm 40 meters from the origin, but I'm 20 meters from my starting position. Okay. So I'm 20 meters closer to my origin. All right. Then it says, number 8 says, if you move at 20 meters, okay, we already did that. Number 9, if you're traveling 55 miles an hour and a car traveling towards you appears to be traveling at 115 miles per hour from your perspective, what is the speed of the car relative to the road? So you're going 55 that way. It appears to be coming towards you at 115. And this is 55. So the other car relative to the road should have a speed of 60 miles per hour. All right, now I'm going to see if I can get to the next page, and we will see what we can do. All right, so I'm going to pause for just a second. Okay, number 10 says, which of the following statements is correct based on velocity versus time graph shown to the right? Well, here's your velocity, here's your time. And we know that the velocity is increasing as the time goes on. So if we take the slope of the line, we can find the acceleration. And they say the acceleration is constant. That would be true because the slope of the line is constant. Acceleration is 0. No, it has a slope. Acceleration is negative. No, it's a positive slope. Acceleration changes. No, it doesn't, because that straight line is the value for the acceleration. How long does it take a caterpillar to crawl 1.3 meters if it moves at a rate of 0.2 meters per second? Well, if speed is equal to distance over time, and you're looking for time, it's just going to be distance divided by speed. All right, toy car is given an initial velocity of 5 meters per second, accelerates at 2 meters per second squared, final velocity of 8 seconds, VF equals VI plus AT. you know this one, you know this one, and you know this one, you can get the final speed. Okay? Large ball composed of human scabs, oh gross, is dropped from a window 15 meters above the ground, hits it 3 seconds later with a speed of 20 meters per second. What is the average speed of the human scabs during the time it falls? Average speed is distance over time. So if you know your distance and your time, you should be able to get your average speed. Okay? A watermelon is dropped and hits the ground in 7 seconds. How far did it fall? Well, we know that this is 0 because it's dropped. We know the time and the acceleration due to gravity, so that's no big deal. A car is dropped from a height of 2 meters. What is the speed of the cat, when it lands on the ground? Vf squared equals Vi squared plus 2AD. You know that. You know the acceleration, and you know the distance that it's dropped, so you should be able to find the final speed. Now, I don't know what y'all do with positives and negatives, but that matters, so pay attention there. Which of the following does not affect an object's air resistance? I would go with mass, okay? Because the size and the shape, if it's like a piece of paper, it's going to have a lot more air resistance than a bowling ball. So the size, yes. Okay, not real sure about that one, though. All right, so let me see what else I can do. All right, let's move on. We tried to answer, oh, where'd it go? All right, here we go. So we got through. All right, now we're on 17. You're walking 2 meters per second toward the front of an airplane, traveling at 245. How fast are you traveling with respect to the ground? 243, I would think. Wait, you're walking toward the front? No, 247. You and them are both going the same direction. Car reduces its speed from 4 to 2 to 10 meters, so if I did that correctly, Vf squared equals Vi squared plus 2AD. You know Vf. You know Vi is 4, Vf is 2, D is 10 meters, find A. Car takes off from a stop and travels a distance of 280 meters. If it takes 5 seconds, acceleration, D equals 1/2 AT squared plus VIT, but we don't care about VIT because that is starting from rest because it was stopped. So you know your distance and you know your time. Find your acceleration from 0 to 30 and with that. Okay, so same thing here as that equation. Vf squared equals Vi squared, so that's 0. You know this is 30. You know this distance is 45 minutes. Find your acceleration. Okay. All right. So let's look at this next little rascal. Your unit review over graphs. All right. So it says, what is the slope of this P versus T graph represent? Should be the average speed. Constant positive velocity are the ones with positive slope. Constant negative velocity, one that has a negative slope. No motion means no change in position. Which slope shows the greatest positive velocity, the steepest one? Which slope shows an object moving towards the origin? I would think that it would be the one with a negative slope. What is the average velocity of the object from 0 to 5 seconds? I guess we're talking about this one. So take the slope of the line for the first 5 seconds. Average velocity from 10 to 12.5. Take the slope of the line from there to there. What is the displacement that occurred from the start? So area under the curve. Oh, no, not area under curve. I lied. So displacement is a vector quantity, so you have to look at the positive position, the 0 position, and the negative position. So from the beginning to the end, it looks like it returned to the origin. I would say it has 0 displacement. All right, what does the slope of a V versus T graph represent? Acceleration. Between which points is the speed decreasing, increasing, or 0? I guess they're talking about here. So you're going to look for an increase in slope for the speed to be increasing, or a positive slope for it to be decreasing, let it be a negative. Here it goes back to the origin and through the origin. Here it goes back toward the origin. Between which points is the acceleration 0? He doesn't seem to be accelerating here or here or here. Circle and label where the motion is away from the origin, so you're accumulating velocity away from the origin. Circle and label where the motion is towards the origin, you're coming back to the origin, and what is the average acceleration from D to E? Take the slope of the line. All right, let's see. What does it say here? It says draw the V versus T graph for the position versus time. And then if it's position versus time, you draw the velocity versus time graph. And if it's a velocity versus time graph, then you draw the position versus time graph. So you're going to take this information from here and transfer it onto here. Does not move here. It's accelerating here, so you want to show the velocity increasing and then no velocity at all. Here it's an increasing velocity and a constant velocity, so it's accelerating, and then it's got a constant velocity, so it moves with a constant speed. Position versus time, positive velocity, no velocity, negative. Positive velocity down to negative, so it's going back toward the origin. The speed is changing. It's getting less and less positive, and then it becomes more and more negative, so be careful when you draw that. You want to show that it's going back toward the origin with a decreasing speed, and then it's going away from the origin with an increasing speed. That means it's accelerating, and there should be some curve in your answer of position versus time. All right. Then we want to go here. Describe the motion represented in the P versus T graph below. I guess this is it right here. So you need to talk about that has a constant speed, then it accelerates. Determine the average velocity from 2 to 4. So take the slope of the line. Draw the V versus T graph underneath the V versus. So now you're going to take this information and put it here. So you're going to have a steady speed. Looks like for about the first 4 seconds. Okay. So that means that it's got a constant speed, and then the speed changes. It becomes more and more positive slope. So that's what you'll draw down here. Draw the P versus T graph below for the motion represented to the right. So constant speed, no speed, constant negative speed. So you need to show a slope of 2, a slope of 0, and a slope of -1 in this position right here. 7 says a ball is tossed up in the air and it comes straight back to its original position. Draw the P versus T and the V versus T graph below that represents the motion. So we want it to go away from the ground and then back to the ground. And remember that there's acceleration there. So it's got to be slowing down, so you need a curve to show that it's covering less and less speed as time goes on. And then on the way back down, you need a curve to show that it's gaining more and more distance, covering more and more distance as it comes down. The velocity goes to 0, so you need to show that, and then the velocity goes back to whatever it was that it started with. And I don't know how to do these because of the way y'all do your positives and negatives, I'm not sure. Okay, but you should be able to do that by now. And then, or 8, graph to the right, at which letter is the object positively accelerating? So you're looking for a positive slope. Object negative acceleration, so you're looking for a negative slope and a negative slope, no slope, no slope. If the object in the graph to the right started from rest, what is the final velocity after it has traveled 4 seconds? Well, its acceleration is 2 meters per second squared. I guess it's meters per second squared for the whole time. So you should be able to do d is equal to 1/2 at squared plus vit. Vit will be 0 because it started from rest, and you should be able to find, oh wait, you want the final velocity. So you should be able to do vf equals vi plus at. Vi again is 0, a is going to be 2, and t is going to be 4, so it looks like it would be 8 meters per second. So I think that kind of takes us through this review. Hopefully that was of some kind of help. So let's see if I can